Words, the world of data has changed. It used to be simpler. A company had a database, maybe two. A database administrator, the DBA, was the gatekeeper. They were the sole guardian of this precious data kingdom. Their job was to keep it running, keep it safe, and keep it backed up. They held the keys, and developers had to ask for permission to make changes. This model worked for a long time. It was stable, it was predictable. But the internet, the cloud, and the sheer scale of modern applications broke this old world apart. We moved faster, built bigger, and demanded more from our systems than ever before. This explosion in scale and speed put immense pressure on the traditional DBA role. Suddenly, it wasn't about managing one monolithic database. It was about managing dozens, sometimes hundreds of distributed database instances across multiple cloud environments. The slow, manual processes of the past became bottlenecks. Developers, practicing agile and DevOps methodologies, needed to move quickly. They couldn't afford to wait days for a schema change or a new index. The friction between fast-moving development teams and the cautious, deliberate pace of traditional database administration became a major source of pain in many organizations. The DBA was overwhelmed, and the old way of doing things just couldn't keep up. This friction wasn't anyone's fault. It was a natural consequence of technological evolution. The tools and philosophies that powered software development had fundamentally transformed. We had CI/CD pipelines, infrastructure as code, and microservices. Everything was becoming automated, code-driven, and collaborative. But the database often remained an island, a special place with its own set of rules and its own manual processes. This created a two-speed IT organization. The application teams were in the fast lane, while the database team was stuck in the slow lane, causing a traffic jam that slowed down the entire business. Something had to give. The role of managing databases needed to evolve to match the modern engineering landscape. It needed to become less about manual gatekeeping and more about enabling developers. It needed to be less about reactive firefighting and more about proactive engineering. The focus had to shift from simply administering a box to ensuring the reliability of a complex, distributed data service. This need for a new approach, one that embraced software engineering principles and automation, is what set the stage for the emergence of the Database Reliability Engineer, or DBRE. It was time for a change. So, what is a Database Reliability Engineer? Think of a DBRE as a Site Reliability Engineer, or SRE, who specializes in the data layer. The SRE role, pioneered at Google, applies software engineering principles to solve infrastructure and operations problems. The DBRE does the exact same thing, but for databases. Their primary goal is not just to keep the database running, but to make it reliable, scalable, and performant through engineering and automation. They are software engineers who focus on the operational challenges of data systems. They write code to automate tasks that a traditional DBA might perform manually. The core difference is one of mindset and methodology. A traditional DBA's world often revolves around a specific database technology. They are experts in Oracle, SQL Server, or PostgreSQL. A DBRE, on the other hand, thinks in terms of services and reliability. They use code to manage infrastructure, provisioning, and configuration. Instead of manually running a backup script, a DBRE builds an automated system that handles backups, verifies their integrity, and alerts on failure. Their job is to engineer away the repetitive manual toil that consumes so much of a traditional DBA's time, freeing them up to focus on higher-level architectural challenges. This role didn't appear in a vacuum. Companies operating at massive scale like Google, Meta, and Netflix were among the first to realize they couldn't hire enough DBAs to manually manage their sprawling data infrastructure. They needed a more scalable solution. They needed to codify the operational knowledge of their best DBAs into software. This is the essence of the DBRE role. By treating operations as a software engineering problem, they built platforms and tools that allowed development teams to safely manage their own database resources, with the DBRE team setting the guardrails and ensuring overall system reliability. The DBRE is an enabler, not a gatekeeper. They work to provide developers with self-service tools and clear processes. Want a new database? Use the automated provisioning tool. Need to make a schema change? The CI/CD pipeline will test it and deploy it safely. This approach aligns the data layer with modern DevOps practices. It makes the database a first-class citizen in the software development lifecycle rather than a special exception. This collaborative, automation-first approach is the hallmark of the DBRE, representing a fundamental shift in how we think about and manage our most critical data assets. When you compare the day-to-day responsibilities, the contrast between a DBA and a DBRE becomes crystal clear. A DBA is often focused on the health of individual database instances. They perform tasks like manual backups, patch management, performance tuning on a specific query, and user access control. Their toolkit consists of SQL scripts, vendor-specific administration consoles, and monitoring dashboards. They are the go-to experts for deep specific questions about the database engine itself. They ensure the system is healthy and secure according to well-established procedures and best practices. A DBRE, however, operates at a higher level of abstraction. Their primary task is to build and maintain the platform that runs the databases. Instead of manually tuning a query, they might build a system that automatically identifies and alerts on slow queries. Instead of manually provisioning a database, they write Terraform or Pulumi code to define the database infrastructure as code. Their toolkit includes programming languages like Python or Go, configuration management tools like Ansible, and observability platforms like Prometheus and Grafana. They focus on service-level objectives, or SLOs, and error budgets, using data to make decisions about reliability. Collaboration is another key differentiator. A traditional DBA often works in a siloed team, receiving tickets from developers. A DBRE is deeply embedded within engineering teams. They participate in design reviews, advise on data modeling for scalability, and help developers understand the performance implications of their code. They champion a unified team approach where everyone shares ownership of reliability. This close collaboration breaks down the us versus them wall that can often exist between development and operations, fostering a culture of shared responsibility for the entire system's health. This extends to everything from security to capacity planning. A DBA might implement security policies by manually granting permissions. A DBRE will automate access control using tools like HashiCorp Vault and write policies as code. For capacity planning, a DBA might analyze historical trends in a spreadsheet. A DBRE will build forecasting models based on observability data and automate the scaling of database clusters in response to demand. The focus is always on creating durable, scalable, and automated solutions over performing one-off manual tasks. It's the difference between fixing a problem and engineering a solution so the problem can't happen again. So, is the DBRE role here to replace the DBA? The answer is not a simple yes or no. It's more of an evolution. The DBRE is not a rival to the DBA, but rather a response to the changing demands of the tech industry. In many organizations, the two roles can and should coexist. The deep, specialized knowledge of a traditional DBA remains incredibly valuable. The DBRE brings a different complementary skill set focused on automation, scale, and software engineering. The reality is that many teams are creating a hybrid model. Some DBAs are upskilling, learning to code and adopt SRE principles, effectively evolving into DBREs. In other companies, a DBA expert might work alongside a DBRE team, acting as a consultant for complex issues, while the DBREs focus on building the platform. The goal is the same: a reliable, scalable data layer. The path to getting there is simply adapting to use the right skills for the right problem. There is no one-size-fits-all solution. Looking ahead, the future of the DBA role is intertwined with the principles of reliability engineering. The days of the purely manual gatekeeper DBA are numbered, at least in fast-growing tech companies. The industry's trajectory is firmly pointed towards more automation, infrastructure as code, and developer self-service. DBAs who embrace these changes and add skills in programming, cloud-native technologies, and automation will not only survive but thrive. They will become the next generation of DBREs, combining their deep data expertise with modern engineering practices. Ultimately, whether you call the role DBA or DBRE, the mission is converging on a single point: ensuring that data is a reliable and empowering asset. The titles may change, but the need for experts who understand data systems is more critical than ever. The future is collaborative, with DBAs and DBREs working together. The journey from DBA to DBRE is a story of adaptation in the face of incredible technological change. If you found this exploration useful, be sure to like, comment, and subscribe for more content on building reliable systems.